Hello friends, a very good evening to you all. So this is going to be a very important session because I've been getting requests for shooting a video on partitioning of a table. So this is a video on horizontal partitioning where we'll see how we can partition a table horizontally in terms of the record sets. So I would so this video would be very helpful and beneficial to the database administrators and the junior SQL Server developer bees. So please try to get the most out of this video. So what I have here in this session is we are going to we will see a table which is of the name of claims. The schema of this table is as per the code here. So what we have here in this table, it's a hypothetical table for any insurance company which has claims. So it has the ID, the record ID, and the claim number, claim status, claim amount, date transaction, and the city from where this claim had come. And then we have a primary key clustered index on this ID column of this table. So before we get started, let's just first create a new database, and let's call this database partition demo. So we say partition demo. When we say that, what you see here is it's going to create two files. It's going to create an MDF and then an LDF file. So each of these database, when we create, it goes and creates the MDF and LDF file for the database. So now let's go and create this, and then let's check. So what we see here is there is a partition demo.mdf file, and then there is an LDF log file. So for each of this database, we always find these two files created by default. So the MDF file is nothing but the primary file, and then the LDF is the log file where all the transaction log appears. So let's connect this database partition demo, and then when we try to find out, what we see here is we have from sys file groups we have a primary row here. So and then when we just try to say sp_help db for the current database, let's just try to fire this. And then when we say the partition demo, we get is the database details of the database that has been created now. So we are good. So now let's try to create the table and insert some records into this table. So we create this table in the partition demo, and then now we try to insert some records, which I have already created a table and have hosted some records, hypothetical records. So let's try to dump this into the claims table. So I'm inserting these records. Let me pause this out. Right, so we have inserted the records. So I have inserted as many as 6 million records into this table, and so if we select the top 10 records from the table, I just want to show what it looks like. We have the ID, claim number, claim status, the claim amount, date transaction, and the city. So it's all hypothetical data that I have collected, and what I have here is also if we see, I have created the date transactions and based upon them. So these are the four date transactions which belongs to the claim for the claims that belong to 2011, 12, 13 and 14 respectively, and the count. So I have about say 1.5 million records each into these four date transactions. For there were around 1.5 million claims for each of these years, so spanning each of these years. So this is just a sample, a big sample, wherein a table partition would be ideal. So when we have a huge sample or huge size of the table, and then we would want our table scans or the index scans to be minimized, we would go for a table partition, that is a horizontal table partition, which means what we are intent here to do is partition the table in the form of the date transaction. So for each of the dates, the older ones, we will be putting them into a separate chunk of the secondary files. Now what do I mean by that? So as I said, by default what I have SQL Server creates is, it creates a MDF and the LDF files. Now SQL Server also allows you to create NDF files. NDF file is nothing but secondary storage files, and in these storage files we will be storing data, partitioned data. Say we'll be storing 1.5 records, 1.5 million records of 2011 in a separate NDF, and then 12 and 13 in another, and the primary file or the MDF file will host only the records of 2014 claims. So what is it that we are saving out of this? We are saving the index scans, we are saving upon the IO, because if we are trying to access any latest records, the SQL Server will only hit the MDF or the primary file, and will not go ahead and scan the entire thing. And then what we are going to save here is the maintenance. Like if it is a claims which is just for the records purpose, you can mark the secondary files as read only, so that it is kept, and only one time maintenance or one time backup can be done. So only the secondary files or the NDF file can be backed up once, and also the MDF files can be backed up regularly, but the size of the MDF file will be drastically reduced if we are using NDFs, and also the maintenance cost will go down. So considering all these advantages, we'll try to partition this table. So what we do here is, as a first step of partitioning, what we have to do is we have to add file groups. What is file group? So file, like the file that we have here, which is MDF, we will try to create separate file groups which would be the NDF files. Remember, SQL Server allows one and only one MDF files, and it allows multiple secondary file groups, which is NDF files. So we will try to add file group with the name 2011, 12, 13. So this is where we are just trying to add file groups. This is the location of the file group, and this is the we call the file group as transaction 2011 and .ndf. So let's try to create this. So we have created a file group of 2011. So likewise, let's try to create file groups for 2012 and 13. So we are done. So now if we'll go and see at our folder, what we see here is we will see there are 3 NDF files also created. These are transaction, these are secondary files, secondary file groups that we have created. So now let's just go back. Alternatively, if we try to check the properties, we will find there are these many files, their initial sizes and everything. So we can mark them read only. So if you see, the secondary files have the option to be marked as read only. If we check this, it will act only as a read only file. So it means that we are not going to perform any changes to these files. So that's just about it. And next, what we see next as a part of uh, partitioning, what we have to start up with is we have to create a EF a function. So partition function and a partition scheme. So what we are targeting here is we are going to target or partition this table, the table horizontally in the form of date transactions. So we want all the 2011 files or all the 2011 records to be kept in the transaction 2011.ndf. So we want this to host 2011, 12 and then 13 respectively. So that's what we are trying to do. So we have to create a partition function. We call this partition function as a EL function, and then we say as range right for values. Range right for values means anything from X value which is of 2011 dated to this value. So we call it this will form the first partition. The second will be from this till this. So this will be the second second partition function. Likewise, the third one will be between this, and then it will be between 2014, and the last one will be for the primary, obviously. So what we do is we are saying range right from value, so it will start ranging the rightmost value to the uppermost limit. So we are going to create this function, and then once it is done, we are going to create a scheme. So remember, if you want to horizontally partition, you have to create a scheme for the EF function and map it to your file groups. So what does this do is it maps to the values that we have given. So why is it 4 and why it is 3 here? So as we've said, 2011 will map to the highest point to the value less than 2012 101. So this will be forming the first partition, and the last one, as I said, anything from 2014 onwards will go into the primary one. So we create a partition scheme, and then we are good. So now if we look at the claims table, what we have in the claims table, the schema of the claims table, we need to see the schema looks something like this. We have a primary key clustered ID on the ID column, and these are the column details. So now what we do here is let's try to move the data. So this is an already created table, and we are trying to partition a table which is already existing. So in this, what we do is we drop the constraint and move the data in terms of the scheme that we have created, and what we pass is the date transaction column. So remember, what we do is we pass the date transaction column of the claims table based upon the year scheme, and then again partition it, and we are just dropping the constraint. So let's just do that. This will quickly partition a table horizontally. And it will move the records. So I think let me just hit the pause button and resume it once it's done. Right, so what you see is the query is executed, and the table has been partitioned. Now how do I see that the table has been partitioned? So to do so, let's just check. So what we see here is these are the partition IDs, and these are the number of rows that belong to each of these partitions. So if we see that these are the partition numbers. Now alternatively, we can fire this query as well, and it will give you the partition details based upon the partition name. So since now, before I do that, what we next do is we create indexes. We also try to see the performance. So what we do here is we are creating a partition index. So this index is a non-clustered index based upon the date transaction, based upon the scheme. So let's create the index, Let me just pause this. Right, so index is created. Now next what we do is we create a non-partition index, which means we are creating back the primary key clustered index on the entire table. So this is being built on the primary MDF file. So we do that. Again, let me just pause this. This is going to take some time. Right, so it's done. So we have created the two indexes on the on the claim ID. We've created on the same column. The first index is a non-clustered one, which is with the help of the year scheme, uh, the scheme that we had created upon the date transaction. So again, it has a partition. This is a partition index for us, and this is a complete index again on the ID column, on the same column. So now if we try to see, what we see here is we have, we are just trying to confirm the first index is built on the entire table, that is the primary key clustered index, because it's on the primary file group, and the second and all the non-clustered indexes we find that there are four. So what we see here is they are partitioned ones. These are the partitioned index built upon around 1.5 million records each. So now what we go here, we switch on to the next tab, and now let's just try to explore the performance. So quickly we just try to see the performance of each of the indexes. So we are going to use the first set of query, where we have a set of a date transaction and the claim number, and we're just trying to look out for the ID, claim number, claim status from the table, with the hint that we are intentionally want it to use the partitioned index, and then we are finding the same query with the non-partitioned index. Let's try to see the performance of both of them. So I am going to include the actual execution plan and then execute it. And then we'll see what is the performance of each of them like. So what we see here, the performance cost, or the query cost, is for the second option, where we are trying to use the clustered index, is way better. Excuse me. Is way better. So the query, what we can say is the unpartitioned index performs better in this scenario. So we cannot just simply say that the partitioning will help you in this. So it's the query also which is to be taken into account. If we use the second option, if we use a second query, which is again we have a specific ID, again we are querying on the ID, which we are using the different hints, that is a partition and non-partition indexes. Let's execute this and try to check. We get the results, and yet again what we see is the non-partition index is way better. The partition index is costlier in this scenario. So what we can say, which is the scenario in where is our partition index good, and where is it that is going to pitch in with the performance boost that we are trying to gain on. So what we see here is the aggregation. So aggregation queries, where we are trying to aggregate on a particular, based upon a particular scenario, where we are trying to say the query that we have here, we are trying to aggregate the number of claims, total number of claims for a period of between 2011-01 and July 2012-01, and we're grouping it by the date transaction. So in this scenario, where we are trying to aggregate and get the date, in this scenario we will have a performance boost when we hint it with a partition. So as you can see, the partition index is way better. It's performing way better than the complete non-partition index. Again, if we trying to hint a simple distinct clause, also we get a performance boost. So although it's a small boost, yet it is giving you a better query results. So for the aggregation, you have a better scenario. What I want to suggest is, when you're partitioning a table, you should also take into account the queries that you would be firing on the table, and based upon that you can make the judgment appropriately. Now this was a scenario, or this was the complete demonstration of table partitioning, horizontal table partitioning, and when we have a table already existing. What about a table which is new, which is going to be built? So let's try to demonstrate the same. We are going to create a hypothetical claims B table, and again the only difference is, as in the previous scenario what we had said is we are saying on primary. Here what we say is create a table, but create on the year scheme that we have already in place. We have a year scheme defined which uses the partition function. So we create this table. At the time of creation you say use the year scheme that I have created. So I have created a table, and let's try to insert few records into this table. So if we insert 5 records and we check for the partition, we will see what is the partition like. So we can see there are the records that have been populated are populated on in the form of the partitions, and there are 2 records in one of them, and the rest of them have 1 1 1. So these are the 2 records which are in the current partition. So basically, and then again if we look at the files, this is just to show you the database files for this particular file groups that we have. So it has 1 MDF, and then again we have 3 NDF files for this particular database. So this was all for horizontal partitioning, and again, as I said, you can always mark the older records, or the older records which you do not use for any manipulation or updates. You can put them into a partition file group which is of read-only type. It is going to save you a lot of time, and also it will remove a lot of overhead from the SQL Server's heart. So I think in the next demo what I would show is a vertical partitioning, what it is like. Horizontal partitioning is the most common one. Vertical partitioning is rarely used, yet we'll see what it is like and what is the scenario where you would go with the vertical partitioning. Thank you, friends.